Welcome to the Refinery Market webinar. It's really a market plus refinery decisions webinar, and I will explain a little bit later why with the industrial internet of wisdom, markets and technology are all interconnected. But it is the interconnection of all the combust, flow, and treat products involved in liquids, gases, and free-flowing solids for refineries. And we're going to be getting into the market forecasts for IIoT and Remote O&M and the components that are involved. Then we'll just briefly touch on the refinery processes. We envision hundreds of decision systems for refineries. We've set up a free refinery decision system similar to what we're doing in coal-fired power, and I'm sure some of you know the length of detail we've gone into, such as Russ on nozzles for scrubbers and other things in coal-fired power. So we're on the way to do the same sorts of things in the refining industry. There is a lot of activity now on fugitive emission control and ambient monitoring at the fence line, and we're going to spend a little bit of time on that this morning, but creating decision systems in several of the areas there. We're the largest information service on valves worldwide and have been for some time, and so that's another area where we already have, for instance, a decision system on molecular sieve switching valves and several other areas there. And then we will be getting into some of the activities that are going on in the guide, which would be the software and subject matter expert portion of the opportunity, and then also the measurement and control. So we'll be touching on a lot of these different things as we go along today here. So combust, flow, and treat product and service sales to the refinery industry will be impacted by IIoT in many ways. First of all, it's going to increase the size of the market, and it's going to change the route to market. The product offering will need to change based on data analytics, which will make it easier to buy based on total cost of ownership. Some IIoT products can be bundled with the other component products, and so component suppliers can either be a sub-supplier or the supplier, and that's an area to be determined. The industrial internet of wisdom will rise in importance along with IIoT. And if you're connecting all the things, it's equally necessary to connect all the knowledge. So refinery decision systems is being created by the McIlvaine company to contribute to the IIoW, or wisdom. Refineries are embracing IIoT, and this is changing the way they purchase combust, flow, and treat equipment and services. Suppliers need to develop holistic programs, which are discussed in the following sequence of slides. The first step is to make accurate forecasts of the opportunity in each industry. This session focuses on refining purchases of selected equipment and products, along with the three building blocks of IIoT: guide, control, and measure. So in 2018, refineries, this is across the world, will spend $44 billion for selected combust, flow, and treat products and services. More than 50% of the expenditures will be for guide, control, and measure, which are the building blocks for IIoT. Some suppliers just provide one type of component. Others provide multiple components plus guide, control, and measure products. Those component suppliers who have weak IIoT programs will be likely to lose market share to those with strong IIoT programs. And we believe this is across the board with whether you're making valves or spray nozzles, it's applicable to you as well. So we have market reports in all these different areas, and these are just some of the excerpts from those reports to show the relative size. But essentially, the guide, control, and measure is equal in size to all of these components. So it is important to try to get a piece of that pie, and the reason is that piece of the pie is going to be growing much faster. So guide includes the software for process management, data analytics, and the input of subject matter experts. Presently, 80% of the guide revenues are derived by software companies, consultants, and suppliers of miscellaneous products and services. Only 20% are derived by suppliers of pumps, valves, treatment chemicals, and filtration. And by the way, we've been running a number of webinars that show the extent to which a lot of these companies have penetrated the field. The pump companies, the treatment chemicals companies, and so forth. As I mentioned a little bit earlier, Nalco has 24/7 monitoring of treatment chemical additions at plants around the world. So these companies have a range of consulting, condition monitoring, and other guide services. The guide segment will be growing at 10% per year, while the component sales will be only increasing about 4% per year. So guide is going to go from 2018 5.8 billion in refining to over 16 billion in 2028. So the pump portion of that guide could be either high or low, depending on the activity of the pump suppliers, and the same with the valve. So, either valve can increase by $800 million a year with an active program of valve manufacturers in IIoT, and the same in these other areas here. But it actually is much more important than just the increase in revenues per item or per product. It's also going to affect the total products. So refining guide revenues in 2028 will be close to 17 billion. Valve companies could capture guide revenues of between 840 and 1.6 billion, depending on their success in leveraging IIoT. So these revenues are significant. They affect the market share. Let's say in the case of X valve company has a present share of 5% or sales of 24 million. In addition, he has guide sales of 23 million. If in the next 10 years, guide sales only increase to 40 million, shows he has a low impact on the IIoT portion of the market, it is likely that the company will lose market share. In this case, the market share drops to 3% with weak IIoT, but would increase to 7% with strong IIoT. So total revenues for the company in 2028 with weak IIoT would be 416 million. But with a strong IIoT, the revenues would be just under $1 billion. There's also major differences in profits. The company with strong IIoT is likely to have twice the profit margins as the company with weak IIoT. And this is because of total cost of ownership purchases, which are not based on price. So total profits could be as high as 5 times greater for a component company that takes the strong IIoT route. So the stakes are pretty high. Another aspect of this is the centralization of purchasing. We've been running these webinars for all these different industries on a biweekly or a monthly basis. And we're citing case after case where all the components and automation and controls for all the plants around the world are being determined from one location, and at that location they have the feedback from data analytics as to the condition of all the products around the world, and the level of knowledge that it gives these corporate people is very high, and they're going to be the ones that are making the specifications for all their plants around the world. So we are generating forecasts for each of the 550 top purchasers of combust, flow, and treat. And in the refinery industry, we're doing this for 200 different refineries. The top 22 refineries purchase more than 50% of all the combust, flow, and treat products. They range in size from ExxonMobil, with nearly 6% of all purchases, to refineries with just a fractional percent. And as you can see here, we have just prepared a sample of how do we do this for representative companies. The number of world refineries has dropped below 650 while the capacity has been increasing. And in the U.S., refineries vary in size from just 3,000 barrels per day to over 600,000. A number of mergers and acquisitions, including the purchases of the Western Refining by Tesoro, with a new name of Endeavor, just highlight, I think, the fact that you're getting this consolidation of decision making. And there is some activity here in the United States due to the shale factor. And so the refinery business has a hot business to be in the United States. Not going to take too much time on the refinery processes. They do vary. You might have a typical refinery might have 40% gasoline as the end product, but they would vary all over the map here as to what their production ratios would be. The refinery processes are complex and many, and we're really just seeing the main processes here. We are going to be spending a little time on fluid catalytic cracker here and the delayed coker. A lot of the combust, flow, and flow and treatment, not combust, but a lot of the flow and treatment is in the ancillary processes, which would be water treatment, wastewater treatment, air pollution control, supply of gases, compressed air and things for the plants. Refinery decision systems, and the reason that we believe now is the time for the suppliers and the end users to be relying on decision systems for their purchasing decisions is due to the whole new approach that is being generated by IIoT. And we have a whole slide program on that, so I'm not going to try to get into it today, but I think we make a pretty good case that the purchasers in the future are going to be very receptive to working through decision systems that provide the knowledge they need to make the best total cost of ownership decisions. So I've created this Refinery Decisions website, and there are continually being added to it are links to articles like how a refinery significantly reduced fugitive emissions. And you can go in and find that article instantaneously if you click under valves or leak detection, repairs, emission control, or under a BP. The interconnection among individuals can be enhanced by decision systems and the development of subject matter ultra experts. So the subject matter ultra expert would be a subject matter expert who is leveraging a decision system, contributing to it, and enhancing it. Some examples are shown in the following slides of areas that we'll be developing decision systems in. Fluid cat cracking, delayed coker, fence line monitoring, of course, and another one is fugitive emissions control, and the two are related. And we just did an interview with Golden Specialty on some of the ways to address the fence line monitoring problem. So let's just go on here. So here is an example that Emerson has prepared on what they're doing on a fluid cat cracker. So with detection of catalyst flow stability, monitoring unit performance with GC for catalyst regeneration efficiency and minimize the light naphtha losses and so forth. So heat exchangers is a big area with monitoring for fouling rate and an alert when you do have fouling, and then pumps for cavitation detection, vibration, and seal health. Delayed coker valves are a challenge. And this is a tough application for a refinery. The lowest total cost of ownership is less dependent on initial cost and is more dependent on automation, reliability, sealing, and maintenance. In the valve area, McIlvaine is providing decisions on fugitive emission valves, generally molecular Sieves switching. So these are some examples of the things that are in the intelligent system. And here's a link to high performance valves and IIoT. And we do already have a number of decision systems on specific power plant steam valves, molecular sieves, 5,000 PSI valves and things like that. And a lot of the seals and packing choices are important as well. Here's a presentation by Steve Kirk of Crane Pharma and Energy that appears in the decision in the intelligence system that explains why these are critical and how to solve your fugitive emission problems in part with the packing. As I said before, a very important development and concern for the refineries right now is their fugitive emissions, and particularly measuring benzene at the fence line and their new federal standards that do require all the refineries as of this month to comply with a sampling program. And we did this webinar for Golden Specialties a few days ago, and you can see a link to it on YouTube. And it's about a 40 or 50 minute long webinar, so we're not going to try to recreate that today. But I would like Megan and James, if they would, to give us just kind of a summary of what was discussed there and what Golden Specialty is offering.
Sure. Thanks, Bob. This is James Haynes, and I've got Megan Stroud with me. So we work with Golden Specialty. We do air testing, and so specifically for this EPA 325, EPA has come up with this rule that you have to monitor your fugitive emissions from the fence line of a lot of facilities. And so Golden's kind of positioning ourselves to help with that in a lot of ways. Golden's been in the air testing business for over 20 years. We have a lot of experience with air testing. It's pretty much all we do is air testing. So I will hand it over to Megan to start talking about some of what we can do for 325.
Yeah, so I'll start with the sampling kits. Those will provide everything you need for the sample collection procedure for EPA method 325B benzene fence line monitoring. The lab technician at Golden will provide and prepare these sampling kits A and B. They'll be alternated between a 14-day passive sampling period. These kits will include the sampling tube sets, which will have a passive sorbent sample tubes and the caps and containers for those. You'll have 2 wrenches to get those caps off, 9/16 inch and 1/2 inch. Desiccant packages to control and dehumidify the case environment during transport. You'll have large gloves, other sizes if needed. Anti-static bags will be used if perhaps there was contamination suspicion to isolate those tubes. You'll have a clipboard with a chain of custody and pens so that you can document your sampling procedures. They're lightweight and very portable. They can either be shipped or delivered depending on the refinery location. After location, you'll just ship them back and you'll alternate with your B kit as you take out your A tubes. After 14 days, you'll just go ahead and install your B ones right away and document that on your COC. So the sample tube sets contain the passive sampling tubes. They're placed in shelters that will shield tubes from any weather elements. The diffusion caps, you'll take off the storage cap with your wrenches and put on a diffusion cap and insert it into the bracket of your shelter. And a little bit more about the shelters. We can help you get the sampling stations of the shelters set up. We're happy to provide any training, site mapping, and planning of those sampling locations. The size is based on, the amount of stations is based on the size of the refinery. You'll either have 12 or 14. And then I will let James go a little bit more into the sample handling once we get those.
All right, so after you've got your tubes collected, you put them all in the kit, you can send them back to us. You can either ship them or we can pick them up, obviously, if we're local. For each batch of samples that we get in, our lab procedures, we just assign a unique sample ID for the set, and then for each individual sample, everything that we have, all the data goes into our lab database. So all the information that you're going to be giving to us is going to be on that chain of custody form that'll be included with the kit that you'll have. All of your individual tube IDs, your shelter IDs, your meteorological data, barometric pressure, temperature, all that kind of stuff gets recorded and sent to us. And then we'll take the tubes and analyze them. And we've got an analytical system set up with thermal desorption. So we open up each tube and pop it into the instrument, and it goes through its sequence and injects into the instrument, and we'll get a pretty quick number from that. So like I said, we're a very solid lab with lots of air experience. So we have all kinds of QA procedures that we follow to make sure that each step of the way we're getting a good analysis, we're getting a good pull from the tube, things like that. At the end of the process, we will send you a laboratory report. We usually just email a PDF report, but we have all kinds of options available. If you need hard copies, if you need different EDDs of spreadsheets of the data, different levels of reporting, depending on what you're looking for. We can offer all kinds of stuff. And in addition to the fence line monitoring, we also just do general air testing for any sorts of air samples that you might have. So that's how Golden is positioning ourselves to handle the EPA 325 rule.
Well, thanks, James and Megan. And the full presentation is available in a number of different ways, and will be part, or is already part of this free website that is available at least to suppliers for 3 months and to refineries continually in the future. I'd like to turn to Greg Theory of Montrose for your perspective. Craig has certainly created a very interesting complex of companies here. So, Craig, the floor is yours.
Thank you. we offer the same type of services that Golden is talking about with our Enthalpy laboratory, who's kind of worked with the EPA in developing method 325B with the passive sampling tubes. But we also have an emerging technology division now who's working with some of the new optical remote sensing. So it provides a way for people to do the scanning and actually learn about their emissions real time, help them pinpoint where leaks are, and items like that. So there's a number of new technologies out there that are being explored. There's refineries in both the Northern California and the Bay Area Air Quality Management District and Southern California, where they're utilizing this technology right now. It's fully automated, continuous. There's really no calibrations required for some types of this, and can provide some rapid leak detection, concentration mapping, emission flux measurements. And they've learned through this in the study in South Coast Air Quality Management District that the measured VOC emissions can actually be up to an order of magnitude higher than those presently being used in emission inventories. So the feasibility and effectiveness of this new type of fence line monitoring using the optical remote sensing is of significant intrigue to somebody like South Coast. They're actually going to be buying a system themselves. It looks like, I'm not sure which one of the technologies, there's 3 or 4 types that they went through analyzing themselves. And I'm not sure which one they've decided to buy, but the cost of some of these systems to purchase is significant. You're probably from $350,000 to $1 million to buy a single unit for some of these technologies. But for a regulatory body like that, with the number of refineries, they're actually planning on doing it themselves. So they had just done a presentation on that. They're hoping to improve their existing emission inventory estimates, and certainly they get fees and such from some of those things. So it is kind of the leading edge of this type of system, and certainly it also gives the refineries possibility of recovering emission losses quicker and minimizing their leaks. So that's a quick summary of some of the new things to come.
Yeah, that's it's good that you mentioned the South Coast and Bay Area activity as well, because we've been putting articles into the decision system to the effect that in 2020, first was passed in South Coast, and now in the other way around, Bay Area and now South Coast. That by 2020, there's going to be mandatory fence line monitoring and reporting for 15 pollutants, not just benzene. So to the effect that you can get optical sensing rather than a laboratory sampling, potentially could result in some cost reductions, I would think. Would you have any thoughts on that, Craig?
Yeah, they found that actually some of this technology, you actually drive around the refinery on a continuous basis. So when they did some of this in the South Coast study, with the 3 different technologies that they analyzed, they actually found some significant leaks under roads and things like this that really helped the refinery discover and recover product that they were losing that they were not aware of. So absolutely, it could be a plus for them, and certainly as you get to emission inventories and the costs associated with your emissions and those type of things, I think there could be a positive ROI for people, but I'm not an expert in that regard, but I would think that would be a possibility.
Yeah, that's a good point. And some of these optical sensors do provide many pollutant measurements. In fact, we're going to show an Opsis slide here in just a few minutes, and I'll talk a little bit more about that. Again, you've got the main processes, but you've got all these ancillary processes in a refinery, and so we're also looking at remediation. We've We have whole services on remediation and wastewater equipment decisions for these refineries as well. And zero liquid discharge is an area we've been heavily involved in, and it's increasingly being used in the refinery industry. So let's look at the guide, control, and measurement. Some examples from Schneider Electric, which supplies a range of control, measure, and products, guide products for the refining industry. And there's some examples on the following slides. But basically, they provide real-time optimization, supply chain management, and operational training here. And at BP, which was unable to quickly make crude purchasing decisions, they've got a cloud computing and supply chain management software system which reduced decision-making time from 7 hours to 4 minutes. Chevron was having trouble with what was going on in the field because 50% of the upstream assets were non-instrumented. So you've got a mobile decision support system that had all sorts of benefits to Chevron. Ecopetrol at suboptimal operations. So the solution was real-time optimization, eliminated 100% of the bottlenecks by evaluating plant configurations, designing new processes, and revamping older designs. Some other types of examples, Hewlett Packard Enterprise provided complete IIoT solutions to Texmark Chemicals. So these technologies make the refinery safer and much more efficient. And the improvements allowed the company to provide greater business value to its customers. So the Hewlett Packard does offer predictive maintenance software, connecting workers and greater efficiency. WiPro, in this particular case, helped optimize the crude blends. OSI Soft is involved in a number of the refineries. This particular refinery, MOL, is an integrated independent international oil and gas company headquartered in Budapest, Hungary. And it's got 4 refineries and 2 petrochemical plants. And OSI Soft has provided analytics for MOL. And the following slides are from a complete presentation by one of their personnel. So they're using the software for corrosion control and monitoring, feed composition, tracking, and online calculations, and for preventive and condition-based maintenance. So there's an analytics and decision support strategy with distributed analytics, supplemented by offline analysis, and then integrated into the operations. So let's move on then to control and measure. Here's a refinery cooling tower, which was instrumented by Emerson. And the challenges were to have a low-cost installation and increase cooling tower reliability and efficiency. So instrumentation of the critical process variables with wireless transmitter, pressure transmitters, and wireless temperature and pH and other transmitters was the solution. And the smart wireless technology reduced turnaround time and improved operator safety. The fact that is making all of these initiatives cost effective is the low cost of wireless transmission. So that's a big factor in IIoT. Here's an example of a ITT Condition Monitoring system that's on pump at United Refinery, and it's been there for 9 years. And I think this is a perfect example where you have the component suppliers providing what we call the initial software and through an edge computer system that would feed into the cloud system. But the pump supplier is in a good position working with a software supplier to create a method for the pump to operate in the most efficient manner. Back to Emerson, an example again for corrosion monitoring for 4-amine absorbers, and you have these unusual situations like high CO2 content and carbonic acid attack. And the solution was to redistribute the feed so that no one tower was getting this high concentration. And here's another remote monitoring at the Tula refinery by Belden with its connectivity products. And as I was saying before, wireless transmission is the way that this all can be done with minimum cost. And as Bob Karshina pointed out, companies building new refineries are well aware of the benefits of using IIoT through pervasive sensing applications. A typical modern facility will thus have about 50,000 inputs and outputs to and from control and monitoring systems. An older refinery, on the other hand, will only have about 20,000 inputs and outputs. So there's a 30,000 shortfall, which is the root cause of much of the inefficiency, operational issues, and safety incidents. So most of these facilities were designed and built with a minimum amount of instrumentation. So just adding wireless transmission and to these 30,000 additional points is a very cost-effective answer. Back to what we were talking about here on the open path monitoring systems. Here's one that is available from Opsis, and I think Craig was citing, these devices can cost up to $350,000 each. But on the other hand, if a refinery has to do monitoring of 15 parameters and can do a number of them in one device and doesn't have to use passive samplers, that is going to be a potential saving. So this one has nitrogen dioxide, SO2, ozone, specific aromatic compounds such as benzene, toluene, xylenes, and other styrene, phenol, and so forth can all be analyzed. So this is a potentially cost-effective solution for some of the requirements that are becoming up, certainly in the California and other areas. So that is the end of our presentation today. I'd like to see if there's any questions anybody has before we sign off. Anybody have any questions or thoughts that they might want to interject?
Bob, this is Craig Theory. I'm not sure on this, but one of the interesting other spots to look at, another thing that Montrose offers is the leak detection and repair. And a lot of these refineries have people going through and measuring the emissions from each valve, and there's a tagging and inventorying system and some of this. So I imagine, which is another service that we provide, but I think as this real-time monitoring goes forward and stuff, there might be additional savings that way, which we didn't discuss earlier. If you come up with a significant ambient monitoring system that provides real-time detection, it might be able to eliminate. We're also using drones for some of these things as well. So there might be some new ways to eliminate the manual sampling leak detection and that goes on these days with the leak detection and repair method 21, with often referred to as LDAR, with these open systems as well.
Yeah, that probably would be a good interweb view that we could do with your people, similar to the one we did with Golden here. If so, maybe offline we could talk about that. Maybe because we're heavily involved in these fugitive emissions and with all the valve solutions and so forth here. So we'd be interested in doing that. So let's talk about that.
Yes, sir.
Anybody else have thoughts or questions? If not, thanks a lot for attending today. And this is Bob McIlvaine signing off.